Hello guys, today I'm going to introduce the disc clutch. So what is a disc clutch? The function of a clutch is to permit smooth, gradual connection and disconnection of two members having a common axis of rotation, and the disc clutch is a part of the clutch. The figure shows a simple disc clutch with one driving and one driving service. Driving friction between the two develops when they are forced together. So how does a disc clutch work? The figure shows an automotive type clutch used with standard transmissions. This clutch in this figure has two driving surfaces, which is the flywheel and the pressure plate. And also it has two driving surfaces, which are the two sides of the clutch plates. So the flywheel, clutch cover, and pressure plate rotate with the crankshaft. And a series of circumferentially distributed springs or a slotted coned disc spring force the pressure plate towards the flywheel, clamping the clutch plate between them. The hub of the clutch plate is spine connected to transmission input shaft. The clutch is disengaged by depressing the clutch pedal, which rotates the lever marked to release. This pushes the clutch release thrust bearing against a series of radially oriented release levers that pull the pressure plate away from the flywheel. As you can see in this picture, if the release fork receives the force from the clutch pedal, it will pull the clutch disc away from the flywheel. Otherwise, if the clutch disc is engaged, the clutch disc have contact surface with the flywheel, and the spring between the hub and the disc it will absorb shock as the clutch is engaged. So there's also a multiple disc clutches in transmission. The figures at the right side illustrates the principle of multiple disc clutches. As you can see, there is four driving discs and three driving discs. Both of the driving and driving discs have 6 friction surfaces. The clutch can be designed to operate dry or wet. The automotive clutches for standard transmission operate dry, and most multiple disc clutches, including one used in automatic transmission, operate wet. There are some equations to use to analyze this clutch. Those three equations is used to assume uniform distribution of interface pressure. This assumption is only valid for an unrolled clutch, which is the new clutch. F is the total normal force acting on the area of contact. P is the uniform level of interface pressure. T is the total friction torque that can be developed over the entire interface. R is the radius of the friction surface. RO is the outer one and RI is the inner one. N is the number of friction interfaces, such as the last figure, there's 6 friction surfaces. And the small f is the friction coefficient. This one is assumed to be constant. And those 4 equations is used to assume uniform rate of wear at interface. This assumption is only valid for a used clutch, different from the last 3 equations. A new clutch will have a greatest initial wear at the outer radius. After the initial braking wear, the friction lining tends to wear at a uniform rate. This uniform wear is assumed to result from a uniform rate of friction work, a constant product of pressure and velocity or pressure and radius, P multiplied by R equals C, where C is a constant. Pmax is the greatest pressure which occurs at the inner radius. It has a value determined by characteristics of the friction lining material. The assumption of uniform wear rate gives a lower calculated clutch capacity than the assumption of a uniform pressure. Because of this, just an introduction to this clutch, so we're not going to do any examples by using those equations. So that is the end of the presentation. Thanks for watching.